All right, guys, so in this problem number 85, the graph of a function f is shown in the figure. Use the graph to find its value. And what you need to define is f of the value of the inverse of the function f negative 1 of 4. So basically, we have to calculate f of negative 1 of 4. So we need to look at the function f, and what you need to define is the value that the inverse will be when x equals 4. So what do we have? Let me graph the function. So we have a function that looks like, let's say, call this problem number 2. This point number 2, that will be 2, that will be 4, that this is where we will have 4. We have something like this, where we have a 4 right there for y. For x right here, it's also 4. Then we're going to 2 right there, and we end up to go to 4 as well. Somewhere like that. All right, then right there we have 4, and we have negative 4 and negative 2. Just, oops, let me do that again. There we go. And right there we have negative 2 over there. So use the graph to find each value. So remember, if I want to find the inverse of my function, I need to look at basically substituting x by 4 by y and y by x. And when I do that, on this graph representing the function f of x, okay, when I'm going to look at the inverse of negative x, it's exactly if I ended up to have a function where all my y will become x and all my x will become y. So the point right here, which is defined with a value of x equals 4 and y equals 4, is going to be the same, because x will become the y, which is 4, and the y will become the x, which is 4. These two, on the other hand, x equals 2 is now supposed to be y equals 2 for the inverse. So I'm going to be right here. And so the inverse would be doing something like that. Then the point that is right there, which is y equals negative 2, is going to be x equals negative 2. So it's going to be right there. And finally, the point that is negative 4 and negative 4 also right here will be still be negative 4. And the problem that we are seeing right now is directly connected to the next problem, which is going to be 91. You are going to understand in a minute. But once I'm able to graph the inverse, now f of negative 1x, I can see I'm clearly able to say when x equals 4, f of negative 1 of 4 is also equal to 4. Right there, it's also equal to 4. Why do I say that it's related to the problem number 91? Because on the problem number 91, you can see the following graph. So we have, on the problem number 91, we have a graph that looks like this. Let me see if I can represent this properly. And then we have something like that. Approximatively, it's something like this. So what do we have? We have let me represent almost the same color than you have, guys. So this is the function f, the function, not f, this is g. So we have g of x right here. We have f of x right there. And what do we have in the center? In the center, we have the function y equal, we have the function y equal x, and y equal x is the axis of symmetry. And because y equal x is an axis of symmetry between g of x and f of x, y equal x is the axis of symmetry between for g of x and f of x. Therefore, I can clearly say that f and g are inverse. Okay? So how do I check in my previous problem, number 85, that I didn't make any mistake? Well, if you graph the line y equal x, you will end up to realize that y equal x is an axis of symmetry for the blue graph right here, for this blue graph representative f of x, and if I can express with the right color, and for the orange color graph, which is supposed to be the inverse of my function. And so therefore I realize that I can clearly say that these two functions that I graph are really inverse to each other. And so I'm kind of sure now that when I'm looking at x equals 4, the value of f of -1 is also equal to 4. All right, guys, thank you very much. And I will move on to the next section.